Jai Hind friends, I am Himanshu Tripathi and today we are going to study the introduction of 8051 microcontroller, and we will see that how we can write a program in assembly language for 8051 microcontroller using the Keel Microvision IDE. So let's start with the 8051 microcontroller introduction. The first and the very important topic is the block diagram of 8051 microcontroller. Here on the screen you can see the block diagram of 8051 microcontroller. In this block diagram, the heart of the microcontroller is CPU, that is also known as central processing unit. 8051 is 8-bit microcontroller, that means it can process 8-bit data at a time. Like the ALU, that is arithmetic and logic unit of 8051 microcontroller, can handle or can add or multiply or logical operation can be performed on two 8-bit data at a time. That's the main reason we call this 8-bit microcontroller. As we all know that microcontroller is also known as single chip computer. This single chip computer means all the important and the required peripherals which are needed to form a computer are available on a single chip, and that chip is known as microcontroller. So in this block diagram we can see that CPU is available here, and the CPU is being connected with the oscillator circuit. So in 8051 microcontroller, the oscillator is already available on the chip. To provide the required clock pulse to the CPU of this controller, we need to connect an external crystal with this microcontroller, and along with this external crystal, these two capacitors are also needed, and they are serving the purpose of wave shaping, so that a good shape of wave can be transferred into the CPU of this microcontroller. Along with the CPU, other peripherals which are available on the chip of 8051 microcontroller are RAM and ROM. 8051 microcontroller is following the architecture of Harvard architecture. That means there is a provision of two memories. One memory is used to store the code, and another memory is used to store the data. The memory which we are using to store the code is known as ROM memory, that is read only memory, and in 8051 IC that is commercially available in the market, this memory is often referred as flash memory. Flash is a specific or a special type of read only memory. The meaning of flash memory is that we can erase entire memory within a flash of second. So in 8051 we are having 4 kilobyte of flash on chip. That means we can store the code which is size of 4 kilobyte on the 8051 microcontroller. If in case we have code more than 4 kilobyte, or we have certain other data that we need to store into the program memory of 8051 microcontroller, we can use external memory with 8051. The maximum memory that we can interface with 8051 microcontroller externally is 64 kilobyte, and the main reason behind this limit of 64 kilobyte external memory that can be interfaced with 8051 microcontroller is the program counter of this microcontroller. Program counter is a register which is available inside the CPU of your microcontroller, and in 8051 the program counter size is 16-bit. Program counter register serves the purpose that it is used to store the address of next executable instruction in it. So instructions are stored in the program memory, that is ROM, and ROM address can be of 16-bit because these addresses are stored inside the program counter. So if we have 16-bit register to store the memory address, the maximum addresses that we can generate, or maximum memory locations of byte size we can generate, are 2 raised power 16, that comes eventually as 64 kilobyte. That is the main reason Why? We can interface maximum 64 kilobyte of memory with 8051 microcontroller. Another important part is the RAM that serves as the data memory in the 8051 microcontroller. And as you can see in this slide, that RAM that is available inside 8051 microcontroller is 128 bytes only. Actually, as a RAM, we are having two separate sections that we will see very soon. And one section is the user RAM that as a programmer we can use to store any data as a general program or data memory, and another 128 byte memory is reserved for some specific purpose. That specific purpose memory or special function memory is also referred as special function register space. So as a programmer, we can use to store our variables, we can use this RAM of 128 bytes only. So in 8051 microcontroller, we are having 4 kilobytes of ROM and 128 bytes of RAM. Another thing that we are having on 8051 chip is the timer or counters. These are the devices which serves the purpose to count any external event or to generate a time delay, or we can say to generate the precise time delay, we can use timers, and to count any external event, we can use counters. Actually, this is one device which can serve either as a timer or as a counter. On 8051 microcontroller IC, we have two timers and counters. These are referred as timer counter 0 or timer counter 1. Both timers or counters are 16-bit timer counters, and if we are referring them as a timer, we can say that these are 16-bit up timers, and if we are referring them as counter, we can say that these are 16-bit up counters. In this block diagram, you can see one additional timer that is also known as timer 2. This additional timer is actually the part of 8032 or 8052 microcontroller, which is another member of this MCS51 or 8051 microcontroller family. So here our focus is to study only 8051 microcontroller. So I am not including this timer 2 into this discussion. But if we are having a IC of microcontroller which is 8052 variant, then we can use additional timer that is also known as timer 2. Also, I would like to draw your attention here into the ROM section. In ROM section, if we are using 8031 or 8032 microcontroller, these microcontrollers do not have any on-chip program memory. So if we are planning to use this microcontroller in our application, then we need to interface program memory externally with this microcontroller. While if we are using 8051 microcontroller, the program memory available on the chip is 4 kilobytes. And if we are using 8052 member of this family, that is 8052 microcontroller, then the available program memory on the chip is 8 kilobyte. These are the basic differences between different family members of 8051 family. This family is often referred as MCS51, that is microcontroller series 51. After the timers, we can see that there is interrupt control circuitry available inside the microcontroller 8051, and more precisely we can say that in 8051 there are 5 interrupt sources, or there may be 5 interrupt sources, and we can interrupt our microcontroller. Only 5 ways are possible to interrupt. We are not considering reset as an interrupt here in this discussion. All interrupts are basically available into the vector table of 8051 microcontroller, and we have 2 external pins which can be used to provide interrupt signal from any external peripheral or any external device, and these 2 pins are referred as external interrupt 0 and external interrupt 1, which are shown here on the top of this block diagram. Along with these peripherals, we are having bus control unit, which is responsible to control address in data bus if needed, or if we are configuring the pins of 8051 microcontroller to interface additional memory, there may be a requirement of external address and data bus. One serial port is available, and this serial port is UART based. UART stands for Universal Asynchronous Receiver and Transmitter. And to handle the serial data communication activities, we are having two pins associated with serial port, and these pins are known as TXD and RXD. TXD stands for transmit data serially, and RXD means receive data serially. As we all know that our microcontroller serves as a single chip computer, so we may easily interface additional devices or external peripherals to our microcontroller. These peripherals connections require the input or output ports. So in 8051 microcontroller, or in case you are working with 8052, we have 32 general purpose input output lines. These lines or these pins can serve as 32 input output ports. We group these pins or lines with each other, and we can say that we are having 4 8-bit ports available with 8051 microcontroller. These ports are named as P0, P1, P2 and P3. P0 is port 0, port 1, then port 2 and port 3. Remember that all these 4 ports are having 8 pins in this. So, one port can handle 8-bit data, or if we are interfacing any device which require only one pin, we can use the one pin or single pin of any of the port. So, we may make a statement that all these input output ports, these are P0, P1, P2 and P3 are bit addressable. So, we can address, we can use a particular bit of these ports. So, this is the general discussion. Here you can see that I have written interrupt sources 6. There is an ambiguity in this statement, because if you are considering reset also as an interrupt, then you can say then in 8051 microcontroller, interrupt sources available are 6 in number. But if you are considering reset not as an interrupt, then you can say that we are having only 5 interrupt sources. So this is your choice totally. You can decide whether you want to make it 6 or 5. The next thing I want to discuss is the data memory arrangement or data memory configuration inside the 8051 microcontroller. As we have discussed earlier in the previous slide, that in 8051 microcontroller, we are having 128 bytes of data memory. In these 128 bytes, the addresses are required of 8-bit. We can generate address of 128 bytes or even 256 bytes with the 8-bit register. So, every memory location is having address of 8-bit. So, we start from 00H, and if we are considering 128 bytes, then we can go up to 7FH. Here these addresses are mentioned on the very left hand side of this block diagram. This memory is basically segmented or segmentation is not right word. This memory is arranged into different levels. The first or the initial starting point of this memory starts with the memory bank. In 8051 microcontroller, we are having 4 register banks. Remember, register is a unit of 8-bit. If I am talking about register, and if it is a 8-bit register, that means 8 bits can be saved in one memory location. So, in data memory of 8051 microcontroller, we are having 4 memory banks. Each bank is having 8 registers. So, if we are starting from memory location 00H, then we can go up to memory location 07H. These constitutes 8 registers, and this is memory bank 0. After 07H, the next memory location which is available is 08H, and from 08 to 0FH, from 08 to 0FH, there are another 8 registers of 8 bit, and this group of registers is known as memory bank 1. The same case with memory bank 2 and memory bank 3, and memory bank 2 starts from 10H to 17H, and memory bank 3 starts from 18H to 1FH. The interesting point that 8051 microcontroller is having, that we are having 4 register banks, and these banks are known as memory bank 0, 1, 2 and 3. In these memory banks, in all of these memory banks, we are having 8 registers. We named those registers, or company has provided the name to every register or each register. The name of the registers are R0 to R7. Like if we are talking about memory bank 0, we can say this memory bank 0 is having 8 registers, and these registers are named as R0, R1, R2, R3, R4, R5, R6 and R7. The same case, if we are talking about memory bank 1, we can say that memory bank 1 is having 8 registers, and the name of these registers are R0, R1, R2, R3, R4 up to R7. The same case holds true with memory bank 2. This memory bank 2 is having 8 registers, and the name of these registers are from R0 to R7. And interestingly, memory bank 3 is having 8 registers, and these registers are named as R0 to R7. So there may be a confusion if we are writing in our code that we are using or we are transferring data from register R0 to accumulator. So there might be a question that register R0 belongs to which bank, because register R0 is available inside memory bank 0, and memory bank 1 is having one register which is named as R0. Similar is the case with memory bank 2 and 3. To solve this purpose, either we can select the bank or we can use the memory location address to be more precise. Like if we want to transfer data from R0 of memory bank 0 to the accumulator, we can write, instead of R0, we can write memory location 00H. If we want to transfer the data from R0 of bank 1, then instead of R0, we can write memory location 08H. This is the way how we handle these registers and the memory locations. Another most important part of this RAM of 8051 is that there are memory locations from 20 to 2F. Each memory location can be addressed bitwise. Like at memory location 20, we can change any particular bit of memory location 20, because each bit is having the address starting from 00 to 07. So from 20 to 2FH, we call this memory area as bit addressable area. This is very important in any microcontroller in which we are having a limited memory. Like for example, we want to interface a LED with our 8051 microcontroller. To change the state of LED, whether we want to make it turn on or we want to make this LED to remain in off position, off situation, we need only one bit. There is no need to define or to use or engage 8-bit memory location for that particular output. So here we can use 1 bit of memory inside this bit addressable area, and we can save a good amount of RAM in our application if we are following these principles. After memory location 30 to 7FH, starting from 30 and up to the 7FH, this RAM locations are not bit addressable, These are byte addressable only, like they were earlier in memory banks case, but these are not given any name. So we cannot access these location with any particular name. This memory area from 3027FH is known as general purpose RAM area, or in some text it is also referred as scratch pad area. So we can say that we are having 32 registers in the RAM, and we can access those registers either by their name. If we are using the name, then we need to first emphasize or first configure the bank accordingly, and after these 32 locations we are having some bit addressable area, and in this area we can access individual bit of the RAM, and after this bit addressable area we are having 80 bytes of scratch pad area, or you can say general purpose RAM area, and this area can be used as a general purpose RAM. After 128 byte of RAM that we have discussed here, we have another 128 byte of area which is also the part of RAM, and this area is not available to programmer to use it in any general purpose. This area can be used only for some specific purpose. That's why we call this area the SFR, that is special function register space. So here you can see that if we are defining the internal memory of 8051 microcontroller, we can say that we are having internal RAM from 00H to 7FH. This is 128 byte of RAM that is available inside 8051 microcontroller. And from 80 to FFH, this is another section of 128 bytes of RAM, which is also known as special function register space. We will see that what is available inside this SFR space. So this is SFR memory map. Here we can see that at some locations we are allotted with some names, like at memory location 80 the name is given P0, then at 81 the name is given SP, that 82 is also allocated as DPL and DPH is at 82. Then 83, 4 and 5, these locations are empty and no names or no special function is assigned to these memory locations. So here we can make a statement that inside the SFR memory or special function register space, all locations cannot be used, or all registers or all memory locations are not occupied. Only few locations are occupied, and these locations are given a special name and they can serve a special function only. So if we are writing in any of these registers, then they may affect the performance or the working of our microcontroller. These registers cannot be used to store any arbitrary data into this location. These are known as special function registers, and easily you can remember these special function registers, like P0 representing the port 0, P1 at 90H location is representing the P1 port 1, and P2, the address of this P2 is A0H and this is representing the port 2, and P3 is representing the port 3. Most of these, almost all these SFRs are bit addressable. So we can change individual bit of any of these SFRs or special function registers. Some another important SFRs are SP, that is stack pointer, which is basically used to define the stack memory, and DPL and DPH, collectively we are having a 16-bit register that is known as DPTR, and the full form of this is data pointer register. This register is used to access the data from external memory specifically, or if we are saving our data into the code memory and if we want to access that data from the code memory, then we need a 16-bit register to use to store the address of that code memory, because remember code memory can be accessed using 16-bit address only. So DPTR is a 16-bit register, but since the microcontroller 8051 is 8-bit only, So we have divided this 16-bit register into two parts, data pointer lower and data pointer higher. So here you can see that data pointer lower is represented as DPL and data pointer higher is represented as DPH. PCON is a register which is used to power control. TCON is timer control register. TMOD is timer mode register. TL0 and TL1 again 16-bit timer registers. TL0 and TH0 makes 16-bit timer or counter register for timer counter 0. TL1 and TH1 makes 16-bit timer counter register for timer counter 1. SCON is serial control register, SPUF is serial buffer register, IE is interrupt enable register. Here using this IE we may enable or disable any of the interrupt available inside the 8051 microcontroller, and IP is interrupt priority register. Like that means we can set the priority of interrupts using this IP register. Here you can also see that T2 con is available, but if we are talking about 8051 then T2 con is not applicable because 8051 is having only two timer counters and T2 con is not available inside the 8051. But yes, if we are talking about 8052 variant of our microcontroller, then there must be a third timer counter and that timer counter is named as timer counter 2. So T2 con is applicable only in the case of 8052 microcontroller. Similarly, RCA-P2L and RCA-P2H is applicable. These all register TL2 and TH2 are applicable in 8052 because these registers can be used with timer counter 2. Timer counter 2 is a part of 8052 and timer counter 2 is not available inside 8051. PSW is often termed as program status word, or some text also refer as a processor status word. But in case of 8051, the most appropriate terminology is program status word. That is simply you can say it is a flag register of 8051 microcontroller. Accumulator and register B, these are the two registers which we can use as general purpose register. Accumulator is generally used as general purpose register in any of the microcontroller, and register B is having some specific uses like multiplication and division instructions of 8051. So if we are performing multiplication instruction, we can use only two registers A and B. The instruction format is MULAB. If we are using division or we are doing division in 8051 microcontroller, we can use instruction like DIV, that is for division, AB. That means only B register and A register can be used in multiplication and division. Otherwise, we can use B register in some other general purpose operations. Practically it is possible, but generally we used to avoid this B register to be put in any use of general purpose operation. One more important thing, that thing is that by default register bank that is activated or that is available activated when we power on the 8051 microcontroller. So default, whenever we are powering up the 8051 microcontroller, register bank 0 is selected because in the PSW every bit value is 0 and PSW, inside the PSW we have the provision to select the register bank. So by default register bank 0 is activated whenever 8051 microcontroller is powered up, and register bank 1 is default stacked memory segment. Stack is a special kind of RAM or a special kind of memory which acts as last in first out manner. So by default stack memory is represented by bank 1 and the default register bank which is activated on power up is bank 0. So this is the general description of architecture and block diagram of 8051 microcontroller. So in next video we will see that how we can write the code for in assembly language using Keel Microvision IDE for 8051 microcontroller. Till then, stay safe, stay happy. Thank you.